you're also going to have unique things that are unique to a particular application. For instance, within an application, your instruments, the range may be different. So if you look at the breathing regulator, you're going to have an instrument range of 0 to 120. But for a flight regulator, for instance, you may have a different instrument sensitivity, or a different sensitivity to that your unit under test is going to see. So, for instance, the inlet pressure, you may want to have only shown between 0 and 60 psig. Same with your outlet pressure. You may want to have 0 to 3, for instance, inches of water. Now, you would still have the same calibrations.
Individual tasks. Perform all tasks.
So what we're going to do is we're going to change the instruments to 0 to 60 psig, and on the outlet side we're going to have 0 to 2.5. Now this wouldn't be the breathing regulator, this is going to be for the flight regulator. So for the flight regulator, the instruments are going to be different. Again, the calibrations for each of these instruments is going to be the same as for the breathing regulator. It's going to be the same for the entire project. So you're going to have the same calibration objects or files. And then this one right here, let's say we still want to have 0 to 100, that same range that we had for the breathing regulator. So that's going to be the same. Well, again, the calibration is going to be the same, and the instrument range is going to be the same as well for this. So we're just not going to change it. So for the flight regulator, we're just going to go in and simply change the range for instrument 1 to 60. You can see it automatically changes. And instrument 2, we're going to change that range to 2.5. And then for the outlet flow, instrument 3, we're going to leave that 0 to 100. So now if you go to the front page and you go to the breathing regulator, that remains unchanged, 0 to 120 and 0 to 100.
Welcome.
And again, you go to the flight regulator, and the range has changed. So this is unique to an application, the instruments. However, the calibration settings are unchanged. So if you go into the calibration 1, again, as I mentioned in a previous exercise, we're just using a polynomial fit, a simple polynomial fit. But more typically, you're going to put you're going to change that to 0, and you're going to put, you're going to put voltage. 0.1 volts equates to 0.3 engineering units, and then you'd put 5 volts equates to 50.2 or 0.3 engineering units. So you could do that as well. That's more typical. But for simplicity for this tutorial, we're just using a polynomial fit. But at any rate, the calibration objects are common to all applications within a project. Now, actuators are common to all applications. So if we deleted an actuator within any of the applications, it's going to be seen throughout all of them. Or if we add one. So right now we're in the flight regulator, and as you can see, there's 2 actuators. So if we added another actuator, we're going to add one called 3. And we can wire that to the DAC board. We'll call it to actuator, to analog output channel 2. And so you look at the manual control form, it's been added here. And again, that's for the flight regulator. So if we go up,
welcome,
and go back to the breathing regulator,
the breathing regulator,
and go into actuators, you can see it's been added here. So the actuators are common. And again, the instruments are unique to an application. However, each calibration is going to be common to the project. Switches are also common. So if we added a switch, it would be added to all of them, to all applications. Now the PIDs are unique. The PIDs are specifically tuned for not only your equipment, but whatever your unit under test is. So for a flight regulator, it's going to have a different tuning. It's going to have different dynamics than for the breathing regulator, which is a different type of regulator. So what we do is when we copy an application, just like the instruments, we copy the objects or the object files, even though they're unique to this new application. However, you can modify them, and that modification won't be seen in any other application. So if you look at the PIDs, and for simplicity, we never tune them, but the tuning or some of the other properties we can modify to work with the specific application in the specific unit under test or part that you're testing or your system that you're running. So you can change your proportional to 0.5 and your integral to 0.75, and you can even change your switch logic, and that'll be saved for the breathing regulator. Now if you go up to the flight regulator, and you go into that same PID, and that remains the same. So this is a very, very powerful ability to independently tune using for a particular application, and it's necessary. So if you go into your project folder, and again, our project folder is called Breathing Regulator Part 7. That's what we've called it. And again, you have 2 applications, Breathing Regulator and Flight Regulator. And under the Flight Regulator, you're going to have a list of folders. For instance, you're going to have you're going to have instruments, and you have a setup file, an XML setup file for instruments. But you notice that you don't have actuators or switches, which are common. So we only have setup files or folders that contain the setup files for unique items for an application. So you look at the breathing regulator, and that has, an instrument file as well. And that is what allows you to make modifications specific to a particular application. So we have the two project folders. Now, if we want to take a look at the folders that contain the common objects, or the setup files for the common objects, that's called shared files. So again, breathing regulator is the project folder, and you have an application folder for breathing regulator and an application folder for flight regulator, and then you have, again, a shared file, and that would have all the folders for shared objects, so actuators, switches, and so forth. And as a matter of fact, there's also application files which are common as well, including the technical manual. And if you think about it, the technical manual should be common to the entire to all applications, because it's more related to the equipment or the test stand, I guess, for this project. So this just gives you an understanding. All of this is really managed by Hiatronic Development Suite, but it gives you a better understanding of what its capabilities are if you look at the file structure. And you can do things like you can copy and or delete setup files, and it affects the object model. So for instance, if we within the actuator folder, if we renamed the actuator setup file, we'll just put we'll put an underscore just to rename that. And if we reload the project,
the breathing regulator,
and we go into the tree view, it doesn't recognize actuators anymore.
Welcome.
So we'll rename that. We'll put that back the way it was. And reload it. And there are the actuators. There's 3 of them. So we'll delete that actuator that we added earlier in this tutorial. So, because we only need 2 of them.
Welcome.
And again, you go into flight regulator, and it's the same thing. Now there's 2 actuators again. So unique and common objects within a project